One thing we will do in this class is keep coming back to certain topics and layering on top of them a little more. Here's one example. We've already solved equations. The ones we looked at before were considered one-step equations, and I'm going to consider these multi-step equations because they just take additional combining of like terms and simplification as a first step. We did see a little bit of that in the first video of solving equations, but the first thing I'm going to ask, and pause and see if you can come up with the answer, is what does it mean to solve an equation? We have a very specific definition of that, and see if you can remember it. But it is find the value of the variable that makes the equation true. Remember, we talked about how equations have variables, and variables can be any number. But we want to find the one number that would result in truth, that would result in the things on either side of the equal sign being the same. So here's our first equation we are going to look at. 5x minus 3x equals 10 minus 2. And, sorry, 10 minus 12. 10 minus 12. So stop, pause it, try it. As before, we've got our equal sign, and the first thing I'm going to do is just draw the line down from the equal sign so we can separate our equation into two sides. Remember, whatever we do on one side of an equal sign, we have to do to the other. That keeps it balanced. So one thing you'll notice is that this side of the equation, this left side, has two terms. And they are like terms because they both have x's. They both have the same variable. So we can combine them. We can take 5x minus 3x, which is 2x. Remember, we simply add or subtract the coefficients, those numbers out in front. Equals, we bring that equal sign right down the line. And then over here we have the same thing. We have two terms. These are both constants. Remember, a term with no variable, just a number. And we can do 10 minus 12, which is negative 2. So all we've done so far is simplify. Now we actually want to do some solving of the equation. So now what we're going to do is try to get that x all by itself, right? We want to isolate this x, which means looking at the operation that's being done to the x, what action is being done to the x, and we do the opposite, 2 times x. So we're going to divide by 2. We want to cancel this 2 and to change it into a 1. We want just 1x. So we divide both sides by 2. This becomes a 1x, which I can just state as x, equals negative 1. And that is our solution. We can go back up and check that, and it will be a true statement. All right, let's try another one. So 2 parentheses x plus 3 parentheses minus 6 equals 8. Yes. Okay. So again, find your equal sign. Always start by scanning the entire equation. Look at everything that's there. Make some observations. Get a little plan of what you might do. Find that equal sign. Divide that equation into two sides. I can never draw a straight line on this screen. There we go. That's pretty good. So, wow, there's only one thing over here on the right side of the equation. It's just this single 8. But there's all sorts of stuff happening here. Well, when there's all sorts of stuff, simplify it as much as you possibly can. Pretend this side doesn't even exist. And just focus on this stuff, right? Just focus on this stuff and see if you can simplify it. I noticed there's something that looks familiar here, 2 parentheses x plus 3. This looks like when we talked about the distributive property. So we can take this 2, right, because it's 2 times a sum, it's 2 times something plus something, we can distribute it. And that gets rid of those parentheses. Those parentheses are grouping things, and when we're solving equations, they sort of get in the way. We want to break down those parentheses. So we distribute the 2 to get 2x plus 6. Right? We distribute here and here. 2 times x, 2 times 3. And then we bring everything else down because we didn't touch anything else. We just distributed. Oh, still look at this left side and think about some simplification. Look at this stuff. Look at that. We have opposites. Positive 6, negative 6. Plus 6, minus 6. When you add opposites, you get 0. 2x plus 0. I'm going to write it, even though you might not initially. 2x plus 0, I'm going to write it. So we know that that additive identity comes into play. Right? When you add 0, you just are left with what you started with, 2x. And now we're kind of at a situation like the last problem. 2 times our variable means we have to divide by 2. Divide by 2. And we get a solution of x equals 8 divided by 2 is 4. And there we go. And if we could substitute 4 back in here, that would give us a true statement. Okay, let's try one more. Solve. Find the value of the variable that makes the equation true. Negative 7 minus 14 equals 2x plus 7 minus x. Pause the video, try it. Give it a shot. Not bad. I'm going to keep working. I scan the problem. I don't have parentheses. I've got 5 terms, right? We have 5 terms. 1, 2, 3, 4, 5. I'm just making observations. We have no variables on the left. We have a couple variables on the right. We also have a constant on the right. So I also see we can start simplifying each side individually. So we can take this stuff on the left and combine it. We can do negative 7 minus 14, which is negative 21. We can do that. On the right side, we also have a couple like terms, 2x and minus x. So the way that we've kind of been doing these previously is we would flip-flop terms, we would commute terms to get them next to each other. The like terms, I'm going to do that. 2x, I'm going to bring the x over here. Remember, whatever sign is in front of it stays glued to it. Minus x, the plus 7, goes over here, right? We change spots. And now we can combine these two terms. That helps make sure you do the right operation as well. 2x minus x is just 1x. Do we need to write the 1? No, I'm going to, just for now. Equals negative 21. Notice how whenever I do something, I leave the rest of the problem alone. Here, all we did was this. Then we flip-flopped. Then we combined those. Now look what happens. We only have a single variable in this equation. It's right here. You know your goal is to get the variable all by itself. It's on the right side. So let's just leave it there. We'll leave this x all by itself, not touch it, and get rid of everything else that's over there with the x, which would be the 7. So the plus 7 gets undone, right? We inverse it. We do the opposite, which would be subtract 7. Find the line. Go to the other side. Do it over there. Negative 21 minus 7 is negative 28 equals, the only thing left over here is 1x, right? This is 0. So the only thing left over here is x. And hey, there's our solution. X is equal to negative 28. Yeah, I know the x ended up on the right side. That doesn't matter. An equation is the same whether it's this way or whether it's this way. We could rewrite it as x equals negative 28 if we wanted to. Either way is fine.